Thank you very much for having me here. It's a great pleasure. It's a fantastic venue. As Bob says, my name is Ghesquiere. I am not a geographer, but I employ many of them. So I basically live and work trying to advise government on how to manage the risk from adverse natural events that affect them more and more. I'll take you through a journey that will take you first to space, but hopefully we'll get down to Earth, or you'll see that we'll get down to Earth very, very quickly. We'll talk, so it's a bit of a reflection on the evolution of risk from adverse natural events. We'll talk about demography, urbanization, and of course, climate change, which is now the unavoidable topic and kind of the magnifier of many trends that are occurring around the world. And in this process, I hope that I will kind of illustrate what Jeffrey Sachs said in the introduction, that really, in a way, geography really is at the center of sustainable development. I think that, as I said, I employ a lot of geographers. I owe a lot to their analysis and a lot to their help in trying to address this important issue. As I said, I'll take you through space. These are land scan images. I'm sure many of you have know these images and have certainly used them. They're very useful to look, for example, at population density around the world. We can see Paris, London. We can see my own country. I'm from Belgium, and we have fantastic light on all our highways and roads, so we can really see Belgium coming out of there. We can see that Egypt is not a country. Egypt really is a river. Everybody converges towards waterways and transport ways, and in fact, along the coasts. If we move east, and we could have moved in many different places around the world, we can start to see fairly different pictures and quite impressive population density in other parts of the world, particularly in the developing world. We can see Java at the bottom, which is probably the densest part of the world. I feel like I'm really not telling you anything you don't know, since you're all geographer, but I'm getting somewhere here. We can look at the basin of the Ganges there, where probably, I don't know, 50. Since this is an expedition into the future to 2050, we should also, I think, look a little bit in the past, and we think about the Ganges basin, which maybe 50 years ago had, I don't know, maybe 100 million people maximum, which now has probably over 500 million people. We start to see interesting trend. And earlier today, I think we talked a lot about this phenomenon of urbanization, the fact that the world is irreversibly becoming urban. And this phenomenon of giganticism, these megacities emerging, particularly in developing countries. Now, again, we're amongst geographers. We all know why the Indian subcontinent is called the subcontinent. It's not because it's below the Eurasian continent. It's because it's actually gradually shifting moving under the Himalayan plates, and in doing so, raising the Himalayas. And what you have on these charts are records that we have, that I think Roger Bingham has collected, of earthquake of magnitude 7 and above that have occurred in the last 200, 300, 400 years. If you look at those, first you see a pretty well-defined seismic fault there, which we call the Himalayan fault. If you look at these dates, you can see that very few of them, in fact only one of them, the Kashmir earthquake of 2005, really happened in recent times. And it starts to make you think and realize that these 500 million people and over who live on the margin of the Himalaya in the basin of the Ganges are people who have never lived an earthquake and don't have any memory of the risk that it represents. And in fact, these people are now becoming a little bit richer. We're finally seeing some progress in trying to reduce poverties around the world and see some economic growth. And so those peoples are adding probably or they're building probably in bricks now and adding a second floor and then a third floor. And it starts to make you think about the vulnerability and the exposure of these people around the world. I like this this illustration because it is just one little place around the world that gives you a sense that first, and geographers know this better than others, that we actually know where large disasters are going to occur. In fact, this location is where some expect the first mega disaster to occur in the next 20, 30 years, probably by 2050. It also gives you a sense of the scale of the problem. The fact that in our success, in the fact that we are seeing economic growth also lies a big part of the problem, in fact, that people are becoming increasingly exposed. Now, I think the saddest part is this is only one part of the world. We can expand this to, if we only consider seismic risk, we can expand this to multiple cities around the world, whether it's Caracas or Bogota or Lima in Latin America, whether it's other cities in other parts. We can expand this to other hazards. Earthquake, loss from seismic or geological event only represent a small fraction of losses from adverse natural events around the world. In fact, hydrometeorological events represent more than 2/3 of the losses experienced over the last 30 years. And we know that these events are likely to get worse. In fact, if we look, can we go one back? One back? Here. If we look at not statistics from the UN or from the World Bank or people who would try to advocate for more action on addressing the rise in loss from adverse natural event, but simply at figures from the finance industry, we can see this dramatic increase. These are data from the reinsurance industry, which gets published every year and which shows a pretty dramatic increase. And these are only figures of disaster that are register on the radar screen. These are what we call disaster. They're the big events that have a certain scale. We now have more and more evidence that losses from small events that occur everywhere and that are also increase following the same trends represent sometimes 2 or 3 times the losses that register through large disasters. So this is a big problem, certainly, and a growing problem, and in particular in developing countries. And as I said, if the image wasn't bleak enough, we now have this sense that with climate change, we will see an increased variability and intensity of hydrometeorological event. And Deborah already, I was going to say, can we go to the back? I was going to say these trends are not there to go away. We're going to continue to see this urbanization, particularly in developing countries. We're going to see continue to see developing this in the developing world. Okay, Deborah talked about this morning about this study that was done in Dhaka, Bangladesh, which shows how if you project the growth in population and in population concentration, and you combine simply with sea level rise. And in Bangladesh, I want to caution you, it's not just about sea level rise, it's also about the subsidence and the ground going going down, but a simple projection to 2030 show an increase in potential for loss of more than 30 times in just 2 decades. And mind you, this is a very poor country, that there's a population density. I think I'll pass the detail. The same occurs with cyclones and tropical storms around the world. We are starting to see, and we talked a lot about risk and uncertainty, so I want to be careful in the terminology, but we're starting to see an increase in intensity. We're starting to see increase in frequency of intense storm. We see a shift in the path of some of these storms. And in some of our studies, we see that most of the island states, for example, in the Pacific and probably in the Caribbean as well, can expect a continuous increase in losses. And if you know that most of these small island states already see between 3 and 6% of GDP every year affected by adverse natural events. These are very disconcerting trends. So let's go back to the Himalayan fault. This is in Kathmandu, and I think it summarizes the problem in and of itself. And I don't know how many of you have ever walked through the street of Kathmandu or any emerging cities in the developing world, and you see this, and this is, in a way, this is a sign of success, right? This is someone who finally has some income, is providing for his family, has built a second floor and then made a little bit more money and built a third floor, probably rents one of these floors and is trying to take care of his family. But in this success, in the fact that people are finally coming out of poverty also lies a big part of the problem, but also, I would say, a big part of the solution. Because if we can resolve this issue, we can certainly resolve this issue, and we can start resolving this issue. In fact, and again, I want to make this point that geography is at the center. Really, the issue of disaster risk will only be solved if we start to deal with the built environment, if we start to deal with where and how we build new infrastructure around the world. We've done some interesting studies, for example, in Kathmandu, showing that if we, this is actually from David Lallemand at Stanford, if we could only start to apply basic standard, connecting the lintels and connecting rebars in basic construction, over time we could start to reduce the potential loss in many of these places. And in fact, if you realize that over the next 20 years, and that's not 2050, that's by 2034, we will probably build, in fact, in the developing world, we can safely say that in the developing world, we're going to build more infrastructure by 2050 that has been built since the advent of mankind. If we can only make sure that this infrastructure is built at the right place, or at least that we're aware of the hazard to which they're exposed, we can try to make this infrastructure resilient, and in doing so, actually build a more sustainable future. So I'll stop here in the interest of time. Thank you very much.